Are you Any questions? 10? Which is a stronger acid in water, HCl or HI? Is that the one? Okay, so the answer would be neither. And sorry? Well, both of them are very large. Ka. Yes? And actually, that takes us to what I was going to talk about today, which is the leveling effect, which is on page 65. It's just one page. So we'll talk about this and we'll come back to your question because it totally relates to this. What the leveling effect is it just simply states that H3O plus is the strongest, it should say acid, is the strongest acid that can exist in water. So the reason for that is that every time you have a stronger acid, like say, for example, HClO4, which is a strong acid, it will react completely and so that means that all the HClO4, the strong acid, is all gone. And it doesn't matter which strong acid you use. It will be the case for all of the strong acids. So any acid that has a larger Ka than H3O plus, so strong acids are any acids that have a larger Ka than H3O plus. So what that means is that HI may in fact have a Ka value, HI's Ka is greater than HCl's Ka. However, if water is the solvent, is there any difference in how much they dissociate? No. So their Ka values are meaningless in water, okay? They are just very large. So whether you have HCl or whether you have HI, they all dissociate 100%. So any acid stronger than H3O plus will ionize 100%. And so 0% of that acid exists in water because it's all gone. Yes? Now, what if the solvent were NH3? And if you're like, well, how the heck did we get these Ka values if they're just very large? We'll talk about that in a moment. But what if instead of having water as the solvent, we had NH3? Okay. Now remember, with water, H3O plus is the conjugate acid of water. And it's the strongest acid that can exist in water. But what if our solvent were not H2O? What if it were NH3? Who do you think would be the strongest acid that could exist in NH3 as a solvent? NH4 plus. Okay? Any acid stronger than NH4 plus, which is the conjugate acid of NH3, cannot exist in ammonia. So let's go take a look at our table, okay, of values here. And if we had ammonia, here's ammonium. If our solvent were ammonia, that would mean that boric acid would be a strong acid. That would mean that H2PO4 minus would be a strong acid. And all of these would then go to completion. Okay. Now, how much of this do you really need to understand? Not a lot. Okay. Honestly, all you really need to know about the leveling effect is that it makes all the acids above H3O plus all the same strength. Right? All of these ones all have the same strength because they're all strong. You can't be more than 100%. Right? So that's why it's called the leveling effect. It levels all the acids above it. Okay? You don't need to really understand why that is. Quite frankly, I would be hard-pressed to explain it to you. You know, I don't know. But what it means is that if you actually wanted to figure out how did they get those Ka, how did they know that HI is actually stronger than HCl, you cannot figure that out with water as a solvent. You would need some other solvent, and I don't know which one they used. Okay, so all you need to know is that when we are looking at HI and HCl, they have the same strength as far as we are concerned. Okay. The other two things you need to know is that the strongest acid that can exist in water is H3O plus. Who do you think the strongest base is that can exist in water? OH minus. Okay. So, and if NH3 were the solvent, then the strongest base that could exist in NH3 would be NH2 minus. Yeah. So any base stronger than OH, for example, O2 minus or NH2 will ionize 100% to form OH, leaving none of that to exist. So, you know, this might be a multiple choice question. What is the strongest acid that can exist in water? And you would have like HCl, H3O plus, you know, and a couple other weak acids, and you'd be like, H3O plus, yay, woohoo, done. Okay, that's why this is a one-pager, one page. And the reason, like I said, that it is called the leveling effect is it makes all the acids above H3O plus at the same level of strength. Okay? And that's it for that. i.e., it dissociates 100%. Is good. Okay. All right. Let's see what else we got here. Nothing else in there. Any other questions from there? We're ready for our quiz. Oh, yes, we got one here. Yes. No, ionizes 100% is fine. Yeah. Ionizes versus dissociates. Becomes ions. By reacting with water. Ionizes can mean other things. It definitely means becomes ions. In this particular case, it's by reacting with water. If we had NH3 plus H2O, we would end up with NH4 plus OH minus. Those are ionizing. That's not dissociating, because to dissociate means to split apart, okay? And there are times when something can be said to dissociate and it doesn't form ions. There was a question, I think, in the equilibrium section where we had N2O4 gas became two NO2s and two NO2 gases, and that was also dissociating. But usually we mean either an acid is dissociating or some other ionic compound is dissociating into ions. That's usually what we mean. Yes. Because I'm a dummy. Thank you. That should have been a one-way arrow. Yes? Completely or 100%, either way is good. You could say fully, completely, 100%, whichever. Yeah. Yeah? Is 4.2 on the quiz? No, just 4.1. It's a fairly big section, so I think that it deserves its own quiz. 4.2 and 3 will be, I think, in one quiz, I think. Unless I want to do like two smaller quizzes. I'll figure it out. We'll figure it out as we go. Yeah. Someone was asking me when our next test is. I don't know, but I know it's not next week. Okay. Pardon me? I don't know. I don't know when my marks are due. I haven't looked that far ahead yet because I have a deadline today. Today is parent-teacher interviews, so that was my goal. I'm like, okay, parent-teacher interviews, and then I'll think about report cards. Yes. Do you have a final? Yes. We do? Sure. Why not? How much is it worth? 50% of your grade. It should be. When I took my final, when I was in high school, it was worth 50% of my grade. We'll see. We'll see how I feel about it at Christmas. You can be like, Santa Claus, please do not give me a final for Christmas. Yes? We will get a lab before Christmas. We're going to do a lab with some indicators, acid-base indicators.
How much are labs worth?
10%. Because we don't do very many of them. B, I don't want to mark very many of them, right? Like, and C, people don't like they want to do the lab, but they don't want to write it up,
So real.
right? And it's like, let's just do the lab, okay, right? And then they don't want to write it up. And I'm like, well, if you don't want to write it up and I don't want to mark it, then there we are, right? So we will have one formal lab report, but I don't even know if I want to make it worth 10% because that sounds like an awful lot for one lab report. Do you know what I mean? So we'll see where we're at, okay? All right, other questions? Yes. Page 2. '62 number 16. 16 on page 62. Okay, here we have you won't actually get a question like this on your quiz, but you should be able to do it at this point because it is a skill you learned when? Last year. And it is a skill we reviewed at the beginning of this year. So when we have a strong acid and a strong base, how would you predict the products of that reaction? Nope. Because this one is strong and this one is strong. So you don't have to do any of that stuff. Also, what type of base is strontium hydroxide? Arrhenius. So it does not behave like Bronsted-Lowry. You are not transferring a hydrogen. Do you know what I mean? Not in the same way. So what you would do is you would treat this like any other acid-base reaction that you learned in grade 11. How do you predict the products of an acid-base reaction? Pardon me? It's a double replacement. So you combine your outside ions and you combine your inside ions. So what do we get? Our outside ions give us H2O. I'm going to write it as HOH just for now, okay? Just to make it a little easier to balance, but I'll also show you that it can be very easily balanced without doing it this way. Plus, who is our other product? Strontium nitrate. How many nitrates? 2. NO3. And let's stick our states on there. We have a liquid and aqueous. Well, yeah, we haven't balanced it yet. Okay. So then our question becomes, is it balanced? No. So how can we balance it? We have hydroxide and we have hydrogen. And you can balance, if you write it as HOH, you can balance those separately. Like, so don't lump it all into how many hydrogens you have and how many hydroxides you have. So how many hydroxides do we need? We need 2 of them, which also gives us 2 hydrogens, which means we need a 2 here, which is really fortunate because we have a 2 here. Yes? Now, should you not want to go the HOH route, you can simply write this as, of course, H2O. And the thing that you need to realize is that every H2O is made of 1 hydrogen and 1 hydroxide. So you need to have exactly the same number of hydrogens and hydroxides and water, okay? So the number of hydrogens is equal to the number of hydroxides, which is equal to the number of water. So if you say to yourself, okay, what have I got here? I've got 2 hydroxides, right? I've got 2 hydroxides. That means I need 2 hydrogens and 2 water, and I'm done. Yeah? So you don't actually have to do the HOH if you don't want to, if that makes it easier for you. That's also a good way to do it. Or you can just eyeball it. Sometimes people get confused when you've got like bigger subscripts, but that'll do you. So like, what if you had H3PO4? This is the biggest one we'd get, H3PO4 plus CaOH2 that would give us H2O plus Ca3PO4 2. And what I would do is I would first of all balance my calcium and my phosphate. Remember, balance the things with the most complex subscripts first, the highest subscripts first. So I'm going to balance my calcium first, 3. And I'm going to balance my phosphate second, 2. That now means I have 6 hydrogens, which means I need 6 hydroxide and 6 water, and I'm done. So you can do it without that HOH if you want to, but it also works to use HOH. Okay? All right, let us take this bad boy and turn it into a complete ionic equation. What is HNO3?
H plus.
Pardon me? The coefficients? Yes, you must use the coefficients. So what have we got there? We've got 2H plus 2 NO3 minus plus SR2 plus 2 OH minus goes to, what do we do with water? Nothing. Question, Taranya? You can, but I would rewrite it as H2O. I would just, like, if I had written it as say this was HOH. Say I had written it like this. I would just go like this. Right? You don't have to erase it. You can just replace it. Okay? All right, so we got 2H2O, and we have SR2 plus aqueous plus 2 NO3 minus aqueous, and net ionic equation. Who are our spectator ions? SR2 plus is a spectator. Who else? 2 NO3 minus. And I'm really glad we did this one, because is this the correct net ionic equation? 2H plus 2OH minus gives 2H2O? No, you would need to simplify. Okay, so just H plus OH minus gives H2O. So if you have a strong acid and a strong base, the net ionic equation will always be H plus OH minus gives H2O. Okay, that is the every strong acid, strong base.
Well, what if it comes
It forms a what?
Yeah.
Sorry, what? What if it forms a precipitate? Oh, then you'd get a precipitate. Yeah. I'm not that exact. Well, That's not a strong acid. Strong acid. Hold on. Let's look at our strong acids. Okay, so chlorate is soluble with everything. So is iodine, unless it's silver with silver or lead. And those are insoluble hydroxides. What about sulfate? Let's look at our solubility for sulfate. I guess we could like have calcium hydroxide. You're never going to have this. But anyway, let's say we had calcium hydroxide, aqueous, plus H2SO4. Oh. What? Hang on. I don't know, because you're not going to get SO4 2 minus, you're going to get HSO4. So let's just not worry about it, shall we? Let's not worry about it. There we go. Done. Okay, we got other fish to fry today. We only got a 50-minute class, and you're not going to have to worry about that. Okay? Yeah. Good stuff. Any other questions before we move on to 4.2? Yes. Oh, okay. There's not much to it. Yeah, but you can count ions, right? Count ions at the beginning, count ions at the end. You'll be able to tell which one conducts better. Yeah. Okay. We were on 4.2a and we made it to the bottom of page 67. And we learned a few formulas. We learned a formula for pH. We learned a formula for pOH. And we learned a formula for KW. Can you tell me what those three formulas are? Negative log of concentration of H+. Yay! Okay, how about pOH? Yay! And do you remember KW? It is 1 times 10 to the negative 14. And what is it equal to? Yeah, and I'm going to do hydrogen first just because we usually write it first, because it's usually like, HOH. We usually put our positive ions first. Doesn't matter. If you write it the other way, it's also fine. Okay, now if I had... No, we're just going to go with that. Okay, cool. So one thing I want you to notice on here is that when we have a pOH of 0, a pH of 0, pOH is 14. Yes? When we have a pH of 1, pOH is 13. When we have a pH of 9, pOH is 5. What can you tell me about the relationship between pH and pOH? Yes?
Like the concentrations for H plus it starts at 1, but then for OH minus it starts at 10 to the negative 14.
Yes, that is true.
The acidity is increasing.
The acidity is increasing, yes, but I want to know the relationship between these two numbers here. They always, when you add them up, they equal 14. Okay, so we know that KW is equal to, actually I should do it this way. Uh, 1 times 10 to the negative 14 is equal to the H times the OH. And we also now know that that 14 is equal to the pH plus the pOH. Does it seem likely that these two equations are related? Yes. Anyone know how they're related? You log both sides, but you don't just log both sides, you negative log both sides. So let us take, okay, so what we're going to do is we're going to take this equation here. P stands for the power of 10 of whatever it is. So either H plus or OH minus or ... And we're going to do ... now. Okay? So we have, let's take the negative of the log of 1.0 times 10 to the negative 14. And we take the negative log of concentration of hydrogen times concentration of hydroxide. Do you guys know a log rule for when you take the log of A times B? Yeah. Log of A times B equals the log of A plus the, that's not an A, log of A plus the log of B. Okay, if you're like, I don't know enough logs to do this, you don't have to be able to do this. Okay, this is just showing you where it comes from. Okay, but if you happen to know this, isn't that nice? So we can say, okay, that's negative of the log of H plus the log of OH. So basically we have negative log of H plus negative log of OH, right? Because this negative is now here and here. You really don't need to write out this much stuff, but this is just showing you where it all comes from. So now the negative log of 10 to the negative 14 is 14.00. 14.00. And now we have negative log of hydrogen is pH. Negative log of hydroxide is pOH. Is nice? Okay, and this thing is the negative log of Kw. Can you imagine what we call that? Yes. pKw. Okay, so 14 is the value of pKw at 25 degrees Celsius. Is good? Okay. We have like a whole thing on this, but... Huh? Where did I write this? It's just to the right of 4.2a. So, at the same level of acidity and basicity, the sum of pOH and pOH is always equal to, let's say, at 25 degrees Celsius. At the same level of acidity and basicity, the sum of pH and pOH is always equal to 14. At the same level of acidity, basicity, the product of H and OH is also equal to, and again, at 25 degrees Celsius, is always equal to 10 to the negative 14. Okay. If you are given the pH, how can you find the hydrogen ion concentration? Yeah, hydrogen is, so if we look, here's our hydrogen, right? There's our hydrogen. It is equal to, that's a negative, 10 to the negative pH, right? Hydrogen is 10 to the negative pH. Yeah. And if it were 9.97, you could say 10 to the negative 9.97. Okay. This function here, 10 to the x, is also known as the antilog. So another way of writing this would be to say concentration of hydrogen is equal to the antilog of negative pH. Those two mean exactly the same thing. I find this one is much more attractive, yes, because it's just nice and short. But if you want to write this, you certainly can. There's nothing wrong with it, okay? And you should just be aware that antilog is a word that we use, and it means raised 10 to the power of whatever that thing is, okay? All right, if you're given the H+, how can you find the pH? This one we should know. pH is negative log of the concentration of H. There we go. Okay, excellent. If you are given the pOH, now here's all our pOHs. If you're given pOH, how do you find concentration of H? How do we go from there to there? Yes, concentration of OH minus is the antilog of negative pH. How else could we write that?
Concentration of OH 10 to the power of
Negative pH. Excellent. And then, of course, if you're given hydroxide, pOH is equal to whoa, thank you. OH, there we go. pOH is equal to the negative of the log of concentration of OH. There we go. Yay! pKw is equal to the negative of the log of Kw. Yes? Cool. All right. Finding the factor by which hydrogen changes. I think we already did this, didn't we? So if you, I think this is a review. By what factor has hydrogen changed if pH changes from 5 to 2? Haven't we done this already? But it's good review. If the pH changes from 5 to 2, by what factor has hydrogen changed? What you would do is you would say 5 minus 2 equals 3, and it has changed by a factor of 10 to the power of 3. And in this case, because it went from 5 to 2, has it increased or decreased? Increased. Concentration of H plus has increased by a factor of 10 to the 3. This doesn't look right. Cross that out. That's wrong. I need to fix this. Get rid of that. That's wrong. Basically, you just subtract the pHs, convert that to a power of 10, and then you have to think. pH went from higher to lower, so H went from lower to higher. Okay, and then you say it increased. All right, what if the pH changes from 7 to 9? pH, or sorry, the, and this should say H3O plus. Or H plus. Fix. If pH changes from 7 to 9, concentration of hydrogen, has it increased or decreased? Concentration of hydrogen has decreased by a factor of how much? By a factor of 2?
Oh no.
By a factor of 10 to the 2. Yes? Or 100? Is good? Okay. Cool, cool. Blah, 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 blah. Okay. There's some exercises. We're not going to do those. Let's just bomb over here. I don't think we actually have to do very much here. This is page 73. But let's just make sure, because I know some of you are in, grade 11, and maybe you may or may not have done the math associated with this, so let's just go through it really quickly. The logarithm of 1 times 10 to the negative 5 is 5.0. Now, 1 sig fig. And now you're going to hate me. 1 sig fig.
What? Since when?
Oh. Where did this negative 5 come from?
Oh no.
It's the power. Is it anything to do with this? If I was to say 1 times 10 to the negative 5, would you say that's 2 sig figs? Because there's a 1 and a 5? No. So you can't say there's a 1 and a 5. That 5 is this 5.
Wait, this guy.
Yes.
Because it's like the laws of logarithm, so then it's like log of whatever minus log of like minus 5, so then it's like subtraction.
Probably. I don't know. All I know is that the 5 is the exponent. Do we count exponents in numbers? No. We don't say that 1 times 10 to the negative 5 has 2 sig figs. It does not. So why would we say that negative 5 is part of the sig figs later on? The easy way to remember this rule is that in pH, pOH, pKw, only numbers after the decimal are significant. Okay? Oh, not that one. Sorry.
No.
Not KW. pKw, though. So all the P's, P, 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 only numbers after the decimal are significant. Scientific notation, you won't end up because it's a power of 10. Like it's going to be some, yeah, it'll be okay. Yes. Is it too late to ask what a log is?
Oh.
Yeah, no. Not too late to ask what a log is, which is what we're doing right now. When you take the log of something, you're saying, if I'm in base 10, okay, so if my number is 10, and I take the log of it, and this log here has a little 10 down here that we usually don't write because it is the most common logarithm, okay? It says, if I'm taking the log of this thing, then my answer is the power. So if I had a log base 3 of 3 to the 6, then my answer would be 6. Okay? I don't know anyone who takes a log base 3 of anything. Okay? Usually you only take log base 10 of something because 10 is something useful to have lots of powers. Yes? Or you do log base E, and I don't remember much about that. You guys are studying for your quiz for tomorrow. Have a good Wednesday evening, and I will see you mañana.
This is different. It's just like, yeah.